All right, good morning or good afternoon, whatever it is for you, everyone. This is the new unit. So the first lesson of the new unit, Unit 2 on forces in motion. So the first unit is kinematics, which is just about motion. And then the second part of it is dynamics, which is when we talk about forces that cause the motion. So to get started, we are going to just start looking at basic motion, so constant motion, and visualize the what it would look like. And so if you're looking at constant motion, I have a little toy Jeep that you'll see videos of soon here that I always use in class to just show the basic idea of constant motion. Before I had the little Jeep, I'd just get students to walk across the room with constant motion, basically stepping the same amount each time over and each duration of time, right? So if you picture what that would look like here, bumper to bumper movement the same each interval of time, obviously spacing is going to be very constant, right? So that's just a nice visual of constant motion if we were just taking a picture every second or something like that. The dot diagram version of things, one second. All right, here we go. Sorry. With the dot diagram, you just think of that as like sort of the center of the Jeep. They actually call it in physics the center of mass, balancing point, basically. But you picture those dot diagrams, the center of mass all the way along would be like that, right? And so the dot diagram is the same stuff. You get the dots just evenly spaced. So through the magic of smartboard, I can, there's your dot diagram for constant motion. Just intuitive feature of constant motion is just even spacing, right? Even spacing is what we're going for there. And then what else do we have? So if we have something that's speeding up, right? So if we're not constant speed anymore and it's speeding up, then, if it's speeding up, it's going to move a little bit at first, and then it's going to move maybe double that or more or whatever, and then even more, and then even more, and then, even more, and so on, right? And so we're getting increasing spacing. Like that, I can't really do any more dots, I don't think, at this point, based on how I was speeding up. And if it was slowing down, it would be moving a lot at first, and then not as much, and then even less, during each time interval, the distance it travels, right? So it's going to be traveling less and less each time, like that kind of thing. So obviously, increasing spacing for speed. Increasing spacing for speeding up and decreasing spacing for slowing down, right? So the terminology used for this is A with a vector arrow over top of it. We'll see about that soon. But it's the rate of change of velocity. It's like that, where it's a change in velocity over the change of time. I think I mentioned earlier in the year about the triangle meaning change, right? And the fancy word for this is acceleration. Oh boy, acceleration is what we're talking about. Yeah, and so there's actually going to be two types of acceleration. We'll get into that, but in this activity that I'm going to be doing here and getting you to take measurements from, just as a class activity, not as a full lab write-up, you just have an assignment to do with it. It's the homework assignment tonight. So I forget where I was going with that. Oh yeah, so in the toy Jeep one, we're going to do, get on track here. We're talking about if we're trying to, take measurements of uniform motion and we had a real car. Obviously, there's a nice feature in cars that have most have a cruise control these days, right? And so it would keep the speed nice and constant. And in the past, I've done this as like an outdoor activity where we go out in the class as a class and we mark out 10-meter intervals all along the road beside the school, and then I drove along in my van and students took measurements. So you'll see the data from that in tomorrow's lesson. So I'm splitting this lesson up into two parts because I don't want there to be like a spoiler alert situation as to what the graphs look like. But I'll show you the results from the van activity tomorrow. Your results are going to be from the toy Jeep activity. And so what I have for that is some videos that you'll be able to take measurements just like you did in the previous labs. And so here we go. I've got a toy Jeep going along, and I'll just show you the regular speed version of this. Obviously, you can just use the YouTube videos directly if it's easier. So I'll let this play. I'm just going to pause for a sec while I close the door to the hall. All right, I'm back. I don't know if you could hear the noise from the hall, but it was driving me crazy. So, you know. Anyway, so regular speed of this. I'm going now, I guess. All right, my little toy Jeep. Pretty good job at producing constant motion, as you can see. And so there's going to be a slow motion video to be able to read numbers from, and yeah, graph distance versus time, or uniform or constant motion. So that's the first video to do with this. And then the slow motion is the one where you can take data from. So let's see how it looks. Now, I don't have this set up, so it's starting at 0. That's okay. You're just gonna, graph. You could do your data in your table. Let me just sort of show here. It goes down into slow motion mode. Eventually, I let go of this little Jeep, and it starts going, right? So but I'm not worried about that being the particular starting point. You could even just, start it at there. So it's at like 8 centimeters ish, right? Maybe you want to get down to the millimeter accuracy there, since it looks like you can. When you are filling in your table, you have a choice. You could, obviously you're going to choose where you're starting, right? When in the video you start doing records from, and it doesn't have to be the very beginning of the constant motion. It can be anywhere along the way. And so you're gonna have like time 0 whenever you chose to start. And then the distance, you can start with whatever it's at as 0, and then do like basically a final minus an initial. So say we started at 8.3 or something in the video. Then if the next time you stop it, you can actually look here at the 24-second mark. You could call that, you could start here with the table as 24 seconds and the distance as the 8.2 or something, right? That's fine. You can do that. It might be simpler to do that, to be honest. Start with 24 and 8 point whatever. And then you press play. And the nice thing is with YouTube, is it's timing it for you as you go. And so if you pause at some other time, you can say, okay, now we're at, looks like 25, maybe 25 or 24.9 or something. Bigger the screen, the better, maybe for precision there. So now you're at 28 seconds and number. So, you might as well just go ahead with that. What I was saying earlier, though, is you could convert those to a 0, 0, and then that one is however many extra seconds it ran for, right? So in this case, it'd be the 28 seconds minus that 24 seconds. So we're saying after 4 seconds, we're at this location. And again, you could do this location, subtract the original location, and that's how far it went, right? So you could use in here actual numbers. So, numbers from YouTube. Directly. So I think I had like 24 and 8.2 or something, and then it was like 28 and I forget what it was, 24.9 maybe, right? You can just do that. Or you could convert basically to a 0, 0 starting point. And then this number here would be 28, take away 24. It would look nicer in the end if we did this, to be honest. So basically you're saying like 4 seconds later. So you have a 4 as your next data point. And then this number would be the 24.9, take away the 8.2. So easy enough to do, right? So 24.9, take away the 8.2. I wasn't watching carefully. Did I get that? Yeah, I did. So the 16.7. Right, so basically in the time lapse, or not time lapse, but the slow motion video, 4 seconds has passed, and it's traveled 16.7 centimeters. Okay, so that would be kind of nice, and I'm not worried about your data table being 1, 2, 3, 4, 5, 6 seconds directly. It can just be random numbers, right? Random spots, and on your graph, when you're graphing this, you're just going to have dots end up however they end up. You just have to make sure to have your scale numbered evenly, right? And then your numbers plotted where they go. The classic mistake in grade 9 math that I've seen many times, I teach math as well, is the numbers might be like 1, 3, 7, 12, and 28, right? So this should be very uneven spacing. But students will label the axis 1, 3, 12, 28, or whatever numbers I said. And so they end up with like a, perfectly even spacing, even though the numbers clearly aren't even spaced. So obviously label your axis fully and then just put the numbers where they are. Little tip here for when you're choosing the scale. Just if you ever have made a scale where you're like 1, 2, 3, 4 and you run out of room, then you do like 5, 10, 15, 20 and it's way too short. You can help yourself by doing the maximum number minus the minimum number and then divide by the number of spaces, right? So in a case of if you're numbering all the way to 100, 100 take away 0 from 0 to 100, you'd be counting by fives, and that would bring you perfectly to 100 at the end. If you round up a little bit, always say this ended up being like 4.6 or something. Round up to 5, you're going to have your numbers go to your maximum nicely and not waste too much space as long as you don't round up too much. Hope that makes sense. That's just a little pro tip for how to choose your number scales, because I've been there. I know it's frustrating to like choose a number scale and it doesn't work, so you have to erase it and then you try again and now it's too short or long or whatever and you have to erase it again, and just trying to give you a work smarter instead of harder kind of a way of going about it. So the slow motion version, did I start to play that already? Yeah, I think I did. Yeah. So the slow motion version keeps going. Now you're going to have to try to keep track of, how long you've gone in the video. Obviously, it ends up at a new meter stick. So it switches from being, 70, 80, and so on. It's going